This lesson is about scatterplots. So a scatterplot, I'm going to show you an example in just a minute, but for now, the one thing I want you to know is that it shows relationships between two quantitative variables. So it shows a relationship between the two quantitative variables. And when we're working with variables, in this case, we actually have two types of variables that we're going to talk about. So the first one is what we call the explanatory variable, and you may have actually heard this called also the independent variable. And this is often used in order to predict something. We actually sometimes call this the predictor. By the way, if this makes no sense for you now, that's okay, because we're going to do an example in just a minute. The response variable, which you might sometimes hear referred to as the dependent variable, is going to be what we measure. So this will be what we're actually measuring. So I think these definitions are confusing, so we're going to do an example that hopefully will clear things up. So we have two people. Tim wants to know if there's a relationship between height and weight, and Kelly wants to know if she can predict a student's weight from his or her height. So we want to know which is the explanatory variable and which is the response variable. And I'm actually going to start with Kelly. So in her case, she would like to predict a student's weight based on his or her height. And the thing that we're trying to find out, that we're trying to predict, is actually called our response. The thing that we use to predict that is called our explanatory. So in this case, the explanatory is going to be the height. The weight is our response variable. So for Tim, we actually don't know what he's predicting from either thing. We don't know if these two things affect each other or if one would kind of cause the other. So actually there's no way to identify them. So I'm just going to say not possible. And as I said before, we'll do a few examples with these, so don't worry if they're not completely clear yet. The one thing I want to mention about explanatory and response before we draw a scatter plot is that the explanatory variable is generally going to go on your x-axis. The response variable is generally going to go on your y-axis. So those are very important things to remember. You can actually remember that because explanatory has an x in it. So that's how I usually remember it. It also has a y in it, but it starts with that. The x is at the beginning, so that's how I remember x-axis. So we're going to do an example of a scatter plot now. And in this one, we want to show the relationship between sprint time and long jump distance. So if you read through the problem, we're not really predicting distance based on time or time based on distance. So actually, there's nothing we can really say would be classified as our explanatory or as our response variable. We're just looking at the relationship. What that means is that you could put anything that you want to on the x-axis or the y-axis. So you can do sprint time on the x, you can do sprint time on y. It doesn't really matter in this case. Sometimes it will matter, but here there's no clear thing that is predicting the other, so we're just going to put them wherever we feel like, luckily. So I'm just going to do it in the order that they gave us, which was sprint time and long jump distance. As with all things in this class, when you're doing a graph, you must label your axes. It's very important. So I'm going to put sprint time on my x-axis, and it's in seconds. And I'm going to put long jump distance on my y-axis. And that one's in inches. The next thing you do is you have to draw your scale. So for your scale, the easiest way to do it for each one is to figure out what your lowest value is and what your highest value is. So for my sprint time, my lowest value is 5.05. My highest value is 7.25. So I'm just going to start at 5 as my bottom one, and I'll put one for 6, 7, and then 8. So make sure that you try to make your scale even, like go by ones, go by twos. Don't just write down the numbers that they give you for seconds. Same thing for my long jump distance. My lowest number is 65. My highest number is 184. So what I'm going to do is I'm going to start at 50 and just go by 50s. Hopefully yours looks a little nicer than mine because I'm using a stylus. So then from there, we're going to actually plot points for each of these. They do not need to be perfect. Just get the best that you can while you look at, just to show a general relationship. So my first point is 5.41 and 171. So that's going to be around here. So go ahead and just pause. I want you to fill in the rest of the points on your own. And in the end, your graph should look kind of like this. So it's just a series of dots. So we're going to now talk about what you need to look at when you're describing the association in the scatter plot. So the first thing you always need to do is you need to discuss the context of the problem. And I'll explain what I mean by that in just a moment. The other thing is that there are 4 other things that you need to look at. The first thing that you need to look at is called direction. And direction is actually going to be the same as the slope of a line. So it'll either be positive, negative, or actually sometimes you're going to have something where you have no associations, so you don't really have much of a direction, but in general it's going to be either positive or negative. The next that we need to talk about is called form. So form is our shape of the graph. And in this class, you are almost always going to have one that is either linear, or the other way that you would describe it is you can say it's curved, you can say it's nonlinear, but for everything in this chapter, it's always going to be linear. We'll talk about nonlinear quite a bit later on. The next thing you need to talk about is strength. And strength is how close the points follow to your form. So for example, if your form is linear, the strength is how much of a line are they in. So it's how close they follow to their form. And strength, you have a few ways to describe it. You can describe it as strong. You can describe it as very strong. You can describe it as moderate. You can describe it as weak. And you can also describe it as kind of a mix of all of them. So you can also say something like moderately strong. You can say moderately weak. You can say very strong, and you can say very weak. So I listed just a few of them, but there's a few ways that you can talk about it. And a lot of the things about strength are very subjective. So if you can't figure out if something is strong or moderate, do not worry. You're not going to be marked off on that unless you're way off. So the last thing that you're going to discuss is if there are any outliers. And the main thing with scatterplots that outliers are is that they are anything that does not follow the pattern of your graph. So it's not necessarily a really high level or a really low level. It's just going to be something that is a dot that is far away from all the other dots in your graph. So let's talk about the association. And for your convenience, I've actually put the scatter plot in a computer-generated form, so it looks much nicer than the one that I drew. But in the one I drew, you kind of got the general shape, but this is the perfect scatter plot. So we are going to describe the association. There are a few ways that you can discuss it. So I always like to start out by talking about what the overall pattern is. So one thing that I would say for this one would be something like students who took longer to run tend to have shorter long jump distances. So it's always a good idea to start with that or put something like that in there somewhere. The next things are a little easier. So you can also say there is a negative association and the pattern is linear. Now, I'm saying it's linear, it's definitely not a perfect line. So, however, you can see that if you were to draw a line through it, there'd be points on both sides of the line, so it sort of follows a linear pattern. And if you remember from back in algebra when you first learned about slopes, this is a negative slope, so we also say that there's a negative association. So the next thing is you have to look at the line and determine how close are those points to the line. And I'm actually going to say that they're fairly close. Once you see a lot of these plots, you'll see that a lot of them have points all over the place. So this one, I'm going to say the association is, you can either say it's moderately strong or you can say it's strong. The other thing that's important is that there are no major outliers. So the thing in red you'll see, we'll talk about that in the next video, but it's sort of an outlier, but it's close enough to the line that it's not a major one. So a major outlier would be, I'm going to draw one in green for example, if you had something like that, that would be an outlier. Or if you had something way out there or something, that would be an outlier. Luckily, we don't have any of those things, so I am going to say that there are no major outliers.